Hello, boys and girls. Let us discuss today on circular motion. But before going into circular motion, we should discuss about one question in your book. That question is saying, what will happen to a ball which is kept on a moving train and the train is moving with uniform velocity? When the brake is applied on the train, what will happen to the ball? Will it move forward part of the train, or will it go backward part of the train, or it will remain at the same location with respect to the train? So let us try to understand this way. We say that this is your train and this is the ball kept on it. So initially both the train and your ball is moving with the same velocity. There is no relative motion between these two. Train velocity is v, ball velocity is v. When the brake is applied, let us say when your train was here, it applied the brake. Because of applying the brake, its velocity reduced to v prime, let us say that. Whereas at that time, this one is not rigidly attached to the means ball is not rigidly attached to the train. So applying the brake on train will not have any effect on your ball. So ball will continue to move with velocity v. Now because of the brake, v prime will be less than v. If we multiply by the time interval t both sides and say this as d distance, and this as d prime. So your d prime is greater than d is greater than d prime. It means in t interval of time, the ball will move farther than the train moves. So what does this mean? That the ball will roll to the forward part of the train. And this is in compliance with your Newton's first law of motion, where it is said that if a body is moving with a uniform velocity, it will keep on moving with the same velocity unless or until some external force is applied to change the state of the motion. So in this question, your ball will roll forward. So this is the mathematical interpretation. Now we go for circular motion. The circular motion, the name itself suggests the motion in circle, right? So if a body is moving in a circle, it's said to be in circular motion. the body is moving in this circular path, it is said to be in circular motion. So there are n number of examples which you are seeing it in day-to-day life, like your bicycle wheel is doing a circular motion about its axis, washing machine drum, your clock, wristwatch, the earth moving around the sun or the moon moving around the earth. So they are all doing a circular motion. Now since we are studying about the circular motion, so we should be very clear about this term, angular displacement. What is angular displacement? As the name suggests, when the displacement of a particle with time is the expressed in angle, that is your angular displacement. Like if a particle moves from here to here, this is the center. On the circular arc, from A to B, the angle which it subtend or make at the center is called the angular displacement. So theta is angular displacement here. So what does it suggest? That the particle initially was at A, now it is at B, covering this circular arc. So it has a angular displacement, means by angle, in terms of angle it has displaced by theta angle, and that is your angular displacement. Even if the particle, suppose initially it was at A and now it is at B, and these two lines are inclined to each other by theta angle, so we can say that this particle has an angular displacement of theta. Though it is not turning in a circle, but we can say that this is the angular displacement of the particle when it moved from A to B. So angular displacement basically is the displacement expressed in the terms of angle. There is one question, we will discuss on it. By how many degrees does the angular displacement of the hour hand of a clock change each hour? So you are aware that the clock is divided into 12 parts in 12 hours. This position is 12 o'clock position, this is 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, and so on. So how much is the angle during a complete rotation? Means from this point, if you take a complete rotation, so how much angle is getting subtended at center, about the center? It is 360 degree. In the clock, the entire circular dial is divided in 12 parts, 12 equal parts. So means 12 parts constitutes an angle of 360 degree. So what will be the one part from your unitary method? 360 divided by 12, 30 degree. The hour hand of a clock change each hour. The hour hand in 1 hour will move from by one part. If it was at 12 before, in 1 hour it will be at 1. In another 1 hour it will be from 1 to 2. In another 1 hour it will be from 2 to 3. So it is asking about each hour, means in 1 hour how much angle the hour hand will turn. So by one part. So by one part means 30 degree. So you can say that this will be the answer for your part A. Now second question is, the clock is showing 3:30. 3:30 means hour hand is at 3 and minutes is at 30. So you know that each part has further been divided into 5 equal parts for the minutes. Means minute hand from 12 to 1 will move by 5 parts. So if it is said that 30 minutes means each part is 5 minutes. So 30 minutes will be 5 plus 5 plus 5 plus 5 plus 5 plus 5. 6 into 5. So 30 at 30 minutes, the minute hand will be here. So let us make the minute hand at this location. This will be your minutes hand. And the hour hand will be along the 3. So now see number 1, the minute hand, how much degree? So minute hand is 6 part of the hour, right? So it is 6 into 6 part means 6 into 30 degree. Each part is 30 degree. So minute hand has the angular displacement of 180 degree. The hour hand angular displacement 3 parts Suppose it is at 3, so 3 parts, 1, 2, 3. So 3 into each part is 30 degrees, it will be 90 degrees. Now angles in radians. Angles are expressed in two ways. One is in degree, that 1 degree, 2 degree, 90 degree, 30 degree and all. And another is in radians. So what is radian? Is it the same as degree or it is different from the degree? So this is the part of the study about the radians. If a particle is moving anti-clockwise in this circular path on this circle and move from A to B on this circular arc, it is subtending an angle theta at the center, and we say that this arc length is S and the radius of the circle is r, small r. So when we express the angle theta as arc length, divided by radius of that circle, so this one is your radians. Theta radians, you can say, since it is equal to theta. This is not angle, but it is in theta radians. So radians is basically, if you express in word, it is the ratio of arc length through which the particle moved divided by the radius of that arc circle, or the radius of the circle for which this arc was the part of. Arc length is in meter, radius also is in meter, means it is the so it has the unit of length, and this is the ratio. So your unit will cancel out. So is radian is your unitless, no unit, and dimensionless. Since there is no unit, so it should not have a dimension. So radian is unitless and dimensionless. It has not been given the name of angle as degree, rather it has been given a different named radians because it is representing the ratio of arc length by radius of the circle, whereas angle in degree is the inclination of one line to the other line. Now from this equation, like theta is equal to arc length, which we have said S, and the radius is R. If we make S is equal to R, if S is equal to R, so your theta will become, in this case, theta will become R by R. This is your 1 radian. So radian can further be put in words that it is the ratio of arc of length equal to the radius of the circle and the radius of the circle. So when the arc length becomes equal to r, in that case we get 1 radian. We will further come into the solution how the radian is related to degree. So these all are conceptual things which you should focus on. The same thing has been put in words. The angle subtended at the center of the circle by an arc of length equal to the radius of the circle is your 1 radian. It is basically 1 radian. Angular displacement we have already discussed about, but as per your book, the definition is written like this, so you can follow this as well, you can write this as well. The angle of arc through which the object has moved from its original position or from its starting position. And subtended is angle between the two lines, means when the two line meets, the angle which it makes, the angle which it makes is called the angle subtended between the two lines. This we have already discussed, so this is there in your definition as well. Theta is equal to in radians, where theta is equal to arc length by radius, where theta is in the angle in radians. Now defining the radian definition we have already discussed, but defining the radian in terms of degrees, we can proceed like this. When a particle starts moving from point A and goes along this circular path and take a complete turn and comes back to A, so how much angle it makes about the center in degree, 360 degree. Now, as per the definition of the radian, we know that radian is theta is equal to arc length by radius of the circle. So how much distance, how much is the arc length for the complete turn, one complete turn? You know it is the periphery, so it is 2 pi r. If the radius is r, the radius of this is theta is 2 pi radian. In this 2 pi radian angle, how much in degree it rotated through? This line rotated through, or how much angle A has made at the center in moving from A to A? It is 360 degree. So we can say that 360 degree is equivalent to your 2 pi radian. It means 1 radian will be equal to how much degree? 360 divided by 2 pi. So this comes about 53.7 degrees. Sorry. If you calculate, you will get it like this, 53.7 degree. No, 57.3. It means 1 radian is 57.3 degree, equivalent to 57.3 degree. 2 pi radian is 360 degree. So now you can establish a relation for pi, 2 pi radian is equal to 360 degree. So pi radian will be 360 degree by 2, that is 180 degree. And same way you can go pi by 2 radian will be 90 degree, pi by 4 radian will be 45 degree, and so on. So now you have a tool for converting radian into degree. If the radian is given, you can convert it into degree comfortably. If a radian is given, like x radian, suppose x radian is given, x can be any number. If you want, somebody says to convert it into degree, so what you will do? You can say that this will be the answer in your degree. If some angle is given, okay, y angle, magnitude of the angle is y in degree, y degree, sorry, right is y degree. And if you have to convert it into radian, so what you will do? multiply with this. So this will be in radians. This will be in degree. So this is the first part, and we'll cover further in the next part.